Hello, in this session we will do motor acceleration study for dynamic motor starting. Motor starting study is performed to determine voltage and current during motor starting, during large motor startings or couple group of motors. Motor starting studies are carried out to help ensure that motors will start with acceptable voltage drop. Voltage drop at time of start will not disturb other loads, and motors will accelerate within acceptable startup times. In this system we have synchronous generator, wind turbine generator, and 4 motors which are connected with variable frequency driver. Variable frequency driver is commonly used to control the speed of the motor. To run motor acceleration study, we have to click on motor acceleration icon. On the right side we can see two types of study. First one is static motor starting, second one is dynamic motor starting. In this study we will do dynamic motor starting. To provide dynamic motor starting, first of all we have to define cases. To define cases we have to click on motor starting study case. We have to click on study case and we can edit, we can define our events. I already defined all the events, and first event is to start motor after 1 second of the simulation. Second event is to start motor after 2 seconds of the simulation. Motor 2 start, and the last event is to start motor 4 after 7 seconds of the simulation. Total duration of the simulation is 10 seconds. I will make inactive the motor starting for motor 2. In the first part I will start only motor 1. We will do motor starting only for motor 1, and we will disconnect our variable frequency driver. So motor starting will be performed without variable frequency driver. At the end we will compare the results of the voltage and inrush current of the motor with and without variable frequency driver. Let's run dynamic motor starting. As we already defined, motor will start after 1 second of the simulation, and we can check the results here. So after 1 second of the simulation, motor 1 is started, and as per the results which we get, bus bar 5 voltage drop at bus bar 5 is reaching around 17%, 17.2%, which is not acceptable. And we can check our results in motor acceleration plots. If we check bus bar 5, voltage at bus bar 5, we can see that voltage drop after 1 second of the simulation, when motor 1 is started, is reaching 81% of the nominal voltage, which can damage other loads. At the same time we can check current of motor 1, and in rush current at motor 1 is reaching more than 5 times of nominal current of the motor. Let's edit our study case, and in the second one I want to start motor 2. After 2 seconds of the simulation and without variable frequency driver. I want to start motor 1 and motor 2 without variable frequency driver. And let's compare the results with the first scenario. As we already mentioned, after 1 second of the simulation, motor 1 will be started. And after 2 seconds of the simulation, motor 2 is started already. So in this case, voltage drop is reaching around 20.5%. It is higher than the previous study, because we are starting 2 motors without variable frequency driver, and at the same time we can check the generator operating regime. In this case, it is operating at 168% of nominal capacity, which is not acceptable. So let's check our results in motor starting plots. In motor starting plots, we can check the motor starting for motor 1 and motor 2, and let's click on the current, and it can be seen from the graph that after 1 second of the simulation, motor 1 is started and it is reaching around 5 times of the nominal current. In rush current is reaching 5 times of nominal current, and after 2 seconds of the simulation, motor 2 is starting, and at the same time we can check the generation on the current of the generator, and it can be seen that after 1 second of the generation, which we have this value, and after 2 seconds of the simulation, the generation of the synchronous generator is increased because of the second motor. Also, we can check voltage at bus bar 5. Voltage at bus bar 5, after starting of the second motor, it is reaching 79.5% of nominal voltage, which is not acceptable, which can damage the loads at different bus bars. So in the next case, I want to run dynamic motor starting with variable frequency driver for motor 1 and for motor 2, and I want to compare the results with the previous one. Let's run motor acceleration study with variable frequency driver. As you see, both variable frequency drivers are connected to the system. So motor is connected to the system with variable frequency driver. After 1 second of the simulation, voltage at bus bar 5 is reaching 98.31%, which is within acceptable limits. Acceptable limits as per grid code, it is plus minus 5%. And let's check after 2 seconds of the simulation, or after 2 seconds of the simulation, it is keeping the same level. We can check the results in motor acceleration plot. And as per the results, as you see, there is no changes, that much changes on motor acceleration study, during motor acceleration study with variable frequency driver. And also we can check generator, and generator is generating within its installed capacity. Thank you very much.